Good morning. Good morning, everybody. Namaskar. Good morning, everybody. Namaskar. This is Engineer Suraj Singh speaking for Bharat India on this day, December 23rd, 2021, Thursday. Good morning, 3:45. मैं सूरज सिंह भारत इंडिया से बोल रहा हूँ। आज दिसंबर 23, 2021, बृहस्पतिवार सुबह के 3:46। Title of talk is same as usual: Civil Field Engineering, Life Engineers, Concrete Specifications, Quality, Contracts, and you can say FIDIC, Standards, Construction Method Statements, Contracts, etc. as usual. Very same as I said, quality. Very important point of quality. As usual we talk of, हमेशा बात करते हैं क्वालिटी की। और अब तो मुझे अभी कह सकते हैं आप, you can say that I am sick of this. You may call me quality phobic. You can call me, no problem. I don't mind that. You can call me that I have become sick of this. Yes, I have become sick of this. I can't tolerate what's happening. You can say everything you see in market, you don't find quality anywhere, and that's problematic, And you can see my address, my identification. This is my ID, mail ID. Of course, this is my board. This is my identification board. It's also fixed on my wall. This is Suraj_engineer@yahoo.co.uk. If you like, if you are pleased to raise some question, you are therefore welcome for that question sending to me on this email ID, Suraj_engineer@yahoo.co.uk. Telephone number is also there, but I don't expect any call because it's no use. I believe in confirmed communication, and confirmed communication can come only in writing, and want people write. People should write. They should not just talk on phone and waste time, because writing becomes a record, talk doesn't become record. And that's my concern about specifications and about how to move in this world, and that's very important part in our life. कैसे जीवन में चला जाए, जीवन को कैसे समझा जाए, या बातों ही बातों में दुनिया चलाई जाए, ये ठीक नहीं है। बातों ही बातों में दुनिया नहीं चलती. We have to struggle in life if we want to achieve something. In reality, we have to do that. Unfortunately, sometimes, where does quality exist? I don't know. Quality कहाँ है भाई? Where does quality exist? That question comes to my mind. Where does quality exist? And I think sometimes it is better to answer this question. Where does quality exist? And that answer, at least I don't know where is that. Where does quality exist? Do you know where does quality exist? I would say no, I don't know. I don't know where this quality exists, but it exists somewhere, I don't know where. The question is that. So my question to you is, I wrote some posting also yesterday. That's point. Where does quality exist? My point is that I can answer that. Where does it exist? You can answer also. Where does quality exist? No seriousness has been observed among engineers from all branches about quality requirement. दिखाई नहीं देती कोई भी गंभीरता इंजीनियर्स के बीच में, हर ब्रांच के इंजीनियर के बीच में, कि क्वालिटी गुणवत्ता है क्या. No material in market is available of quality performance, yet quality mark is owned by material manufacturer. किसी भी मटेरियल में कोई गंभीरता नहीं है. कोई भी सामान आप खरीदिए मार्केट से, बाज़ार से, कि इसमें क्वालिटी होगी, लेकिन इसमें क्वालिटी नहीं होती है. लेकिन सबके पास सर्टिफिकेट हैं. हम सिस्टम को फॉलो करते हैं. हर मैन्युफैक्चरर के पास सर्टिफिकेट मिलेगा आपको. सो व्हाट वी कैन से, नंबर वन, नो सीरियसनेस एग्जिस्ट. No seriousness has been observed among engineers from all branches about quality requirement. And number two is, no material in market is available of quality performance, yet quality mark is owned by material manufacturer. Where, whether or not private or government, quality exists nowhere. चाहे वो सरकारी हो, चाहे निजी हो, गुणवत्ता कहीं भी नहीं है. I am sure that engineers have forgotten quality or they did not study what does quality mean. मैं विश्वास के साथ कह सकता हूँ कि इंजीनियर्स अभियंता गुणवत्ता भूल चुके हैं या उन्हें सिखाया नहीं है पढ़ाई में कि क्वालिटी का मतलब क्या है. Every organization is certified by quality system, but existence of quality is poor. हर ऑर्गेनाइजेशन, हर कंपनी, हर संस्थान क्वालिटी सर्टिफाइड है, गुणवत्ता सर्टिफाइड है, परंतु क्वालिटी गंदी है, कहीं नहीं है. गवर्नमेंट लिस्ट बॉदर्स, सरकार को परवाह नहीं है. कंपनीज लिस्ट बॉदर, कंपनीज को परवाह नहीं है. प्रोफेशनल इंजीनियर्स नेवर एवर बॉदर. अभियंता वर्ग, पढ़ा लिखा अभियंता वर्ग, विशेषज्ञ अभियंता वर्ग चिंता नहीं करता इस बात की. इंजीनियर्स आर नॉट वेल ट्रेन्ड टू एन एक्सटेंट क्वालिटी इज कंसर्न्ड. अभियंता वर्ग को इस बात की अच्छी तरह से शिक्षित नहीं किया गया है कि गुणवत्ता क्या होती है. Thousands designers and executives are available, but never deliberate quality. हजारों डिज़ाइन करने वाले इंजीनियर, कार्य करने वाले इंजीनियर साइट पर उपस्थित हैं, लेकिन कभी क्वालिटी के बारे में बहस नहीं करते. क्वालिटी के बारे में क्या कहा जाए, कैसे कहा जाए, समझ नहीं आता क्या किया जाए. इशू तो है, लेकिन किसको बताएं, कैसे बताएं. इसे ही है, क्या यही है जिसे हम कहते हैं अभियांत्रिकी है? इज दिस व्हाट वी डू कॉल इंजीनियरिंग? रियली फेड अप विद नेशन साइलेंस ऑन इश्यूज. वास्तव में परेशान हैं, तंग हैं राष्ट्र की चुप्पी पर इस विषय के बारे में, क्वालिटी, गुणवत्ता के विषय के बारे में. थिंकिंग ऑफ $5 ट्रिलियन इकोनॉमी, सोच रहे हैं हम $5 ट्रिलियन की इकोनॉमी करने का, सोचते रहिए. शैल वी रीच दिस टारगेट विदाउट क्वालिटी? क्या हम इसको प्राप्त करेंगे बिना गुणवत्ता के साथ? कैसे हो सकता है? सिविल इंजीनियरिंग domain is top in delivering unacceptable standards, whereas it should deliver top most. सिविल अभियांत्रिकी एक वो दुनिया है जिसमें सबसे ऊपर के स्टैंडर्ड होने चाहिए, लेकिन सबसे नीचे के स्टैंडर्ड आ रहे हैं. ऐसा क्यों? सिविल इंजीनियरिंग वो दुनिया है जहाँ ऐसे काम चल रहे हैं जो मैं एक्सेप्ट नहीं कर सकता, गुणवत्ता एक्सेप्ट नहीं कर सकती, जबकि इसके सबसे उच्च वर्ग के, उच्च लेवल के, उच्च वर्ग के सामान मिलने चाहिए, कंस्ट्रक्शन वगैरह जो होता है. सिविल इंजीनियरिंग प्रोडक्ट्स आर मेंट फॉर यूज ड्यूरिंग डिकेड्स टू कम, while other products are used only for few years. सिविल अभियंत्रिकी में जो प्रोडक्ट आते हैं, स्ट्रक्चर्स वगैरह आते हैं, वो आने वाली कई दशकों तक के लिए प्रयोग में आने होते हैं, जबकि दूसरे प्रोडक्ट, दूसरे उत्पाद कुछ वर्ष के लिए होते हैं. दिस मीन्स क्वालिटी रिस्पॉन्सिबिलिटीज लाई ऑन सिविल इंजीनियर्स इंक्लूडिंग स्ट्रक्चरल इंजीनियर्स, बट इट डजंट हैपन इन रियलिटी. इसका तात्पर्य यह है कि गुणवत्ता की उत्तरदायित्व सिविल अभियंता के हाथ में होता है, जिसमें स्ट्रक्चरल के अभियंता भी शामिल हैं, लेकिन ऐसा नो कमिटमेंट रॉबर्ट्स. अभियंता लोग सिर्फ डिज़ाइन बन चुके हैं, डिज़ाइन के रॉबर्ट बन चुके हैं, कोई कमिटमेंट नहीं रहा. इंस्टीट्यूशंस हैव बिकम नॉन एग्जिस्टेंट. संस्थाएं ऐसे हैं जैसे है ही नहीं. गवर्नमेंट इज नॉन एग्जिस्टेंट. सरकार है ही नहीं. IEI हैज़ फेल्ड इन डूइंग इट्स जॉब. इंस्टीट्यूशन ऑफ इंजीनियर्स इंडिया फेल हो चुका है अपने क्वालिटी का काम करने के लिए, और दूसरे जितने भी गैर सरकारी संस्थान हैं, सोसाइटीज़ हैं, इंस्टीट्यूशंस हैं, have entirely become septic. IEI has failed in doing its job, and all other NGOs, societies, institutions have entirely become septic. Engineers do not have communication and coordination skills. अभियंताओं के पास ना संचार की स्किल है और ना ही तालमेल बैठाने की स्किल. Engineers do not have struggling and encountering skills. अभियंताओं के पास ना संघर्ष करने की शक्ति है, ना उत्तर देने की, बात को काटने की शक्ति है. Engineers have become toys in hands of government and industrialists. अभियंता वर्ग जो है खिलौना बन चुका है सरकार के हाथ का और उद्योग करने वाले के हाथ का, उद्योगी के हाथ का, उद्यमी के हाथ का. Youth or budding engineers must learn, or else no one shall call them engineers. युवा वर्ग, आगे बढ़ने वाला अभियंत्री वर्ग को सीखना चाहिए, सीखना होगा, जरूरी है, नहीं तो उन्हें कोई भी इंजीनियर नहीं कहेगा. Old engineers have lost their quality practical systems. पुराने जितने अभियंता हैं वो अपना गुणवत्ता का जो वास्तविक काम था वो खो चुके हैं. Those who never worked in field decide about education and engineering. जिन्होंने कभी फील्ड में काम नहीं किया वो फैसला करेंगे कि इंजीनियरिंग की शिक्षा कैसी हो. Those who never experience field decide about course. जिन्होंने कभी फील्ड में काम नहीं किया वो आपके कोर्स के बारे में डिसाइड करेंगे. Professors are only theoretical tutors and not pragmatic field learners. जितने भी हमारे आचार्य हैं, प्रोफेसर हैं, वो बस थ्योरी के हैं, थ्योरी सिखा सकते हैं, उन्हें वास्तविक दुनिया से कोई लेना देना नहीं है. जस्ट डिग्रीज आर नॉट एडिक्वेट इवन इफ वन इज ए डॉक्टरेट. खाली स्नातक होना या डॉक्टरेट होना काफ़ी नहीं है, उसके लिए बहुत कुछ जरूरी है आपको करना. I have posted this matter on Facebook. I have posted this matter on LinkedIn. I also posted this on CV. And this is my, you can say, internal fire burning, what I have seen. It's very important that we should think of this in line to get what we are talking of about communication coordination. And that's why I'm saying, where does quality exist? That's the main point of this noting. Where does quality exist? Does it? That's why I say non-seriousness and market, you can see rubbish material. In market, every material is rubbish. Nothing if you don't produce quality materials. Government and companies become useless. Professional engineers do not act according to what they should do. Training is absent. Thousands of designers and executives, but no deliberation. Quality. Does it engineering mean? Is it what we say engineering? We are talking of a lot about this economy, that economy, but you think without quality, can you go? Can you think that without quality, can you sell your product in a competitive market? Civil engineering domain is top domain, should remain on top, but it's on bottom. Because we don't care. Where is quality? Only product, that is civil engineering, which runs for many, many decades, but we don't run. Other products are only meant for, even car is meant for a few years. Every material which doesn't belong to civil engineering works only for a couple of years. It may be HVAC material, it may be electrical material, only civil material that goes for decades to come. What happens? Machines don't work forever, electrical appliances don't work forever. This means quality responsibilities lie on shoulders of civil engineers, but where are shoulders? I don't find any shoulders here. Only design is not enough. Commitment is important, and don't become robots. We have to be robots. Who are these? They are only by namesake for quality. They don't care. I don't know what is behind that. We have institutions. I think we have many institutions in this country. Number one institution is Institute of Engineers India. which is they call themselves the biggest professional body in this world. But where is quality? What did they contribute to quality? Just conducting seminars and congresses, I think is enough. Means just deliberation. Where is that? Nothing is done. They're not teaching people. They're not teaching engineers. Means they themselves are engineers. Every member is engineer. But I have written many times, and this is in the picture. Just paperwork is not enough. You should see that you have thousands and lakhs of members. Where is quality? Who is to question them? Government is non-existent. There is no government at all who can take care of quality. Where is quality ministry? Where is quality question? I'm talking of particular engineering quality, forget other qualities. Where is communication of quality? Where is coordination skills? I don't find any engineer talking in a practical way, talking in a good composed language. You can see what they write. They don't even know how to raise questions, how to coordinate. Without coordinating, they raise questions. This happens. Coordination skill is absent, which is very important for engineers. Communication and coordinations are birthrights of people. If you cannot communicate, how can you move further? And there's a coordination. Engineers do not have struggling and encountering skills. You can't struggle. You want answers immediately from seniors. Why don't you do yourself something? And why don't you raise questions when you accept something? Means why you worry about engineering doesn't mean you worry about. Even if you're wrong, you have to raise question. Because you have to clarify. You want to get clarification. Seeking clarification is not something wrong, it's right. And why to be toys in hands of government, hands of industrialists? Nobody can speak against government because they are afraid of job losing. We are industrialists, what they're doing. They just want to make profit. They're more interested in economy, not in quality. Buy any material, you won't find anything. I've experienced many materials. I didn't find any material in quality or performance. Youth of budding engineers must learn, or else no one shall call them. आपको कोई इंजीनियर नहीं कहेगा. आप चिंता ना करें, कोई इंजीनियर नहीं कहेगा आपको. It's very big question mark. Very big question mark. Where is education system? Who is responsible for that? Is minister capable of that? Is professor capable of that? Who is capable of that? What is done in engineering? That should be a part of education and not imaginary theory. Theory should be there, but where is practical? How much practical do we learn in education system? Not even 1%. Nothing. And those who never have been to field, who never have been to sun, who never have been to wind, they decide about everything in codes. How, on what basis? Copying from British or copying from Europe and pasting in your codes. Is that coding? Copying and paste? No. It's not copying and paste. It should be really, where is research? How much are spending on research? We don't want tutors. We want leaders. Professors are just theoretical teachers and nothing else. They're not pragmatic. They don't have experience. And they don't care for degrees. Degrees don't give engineering. These are just certificates, theoretical certificates. I don't care who's a doctor or a master or what. We have I don't want conferences. Talk of facts. I don't want elderly people in conferences. We don't want people who are on top positions, have no experience. I don't want those. So my dear, that's why I say significant it is that we have to understand these points. And that's the reason I started talking of quality. Those singles are down again. Maybe I'm sorry to say I can't go beyond some limit that communication and coordination, which are most significant, but we don't care. We don't care. Why? Because people don't communicate properly and people don't coordinate properly. And when communication coordinations are not available professionally, we cannot do anything. संचार माध्यम नहीं है. संचार माध्यम का मतलब वर्क संचार माध्यम. मोबाइल की बात नहीं मैं कर रहा. अगर आपका प्रोफेशनल कम्युनिकेशन नहीं है तो आप कैसे इंटरेक्ट कर सकते हैं. फोटो को देखने से काम नहीं चलेगा. कोऑर्डिनेशन एक बहुत बड़ा हिस्सा इंजीनियरिंग का. इट्स वेरी बिग पार्ट ऑफ इंजीनियरिंग इन एवरी इंजीनियरिंग, because no information is single-handed, no information is single referenced. There's no one reference that can do everything. So many references are required to move together, even to achieve one activity. Therefore, coordination is very important. People don't coordinate, and that's where we can say people can't get answer. Mistakes are, they make mistakes, and such mistakes, correction or remedial action on those mistakes consume a lot of time. Consumes a lot of time, and we can say in that case quality is lost. Maybe people are not serious about quality, but it's big question mark. Every engineer knows quality is required, but they don't know what's quality. For them, something that what is to be done, and they have to sell, that's all. They have to produce irrespective of knowing what they've done. It happens. I would say in civil engineering, concrete, very significant material. It's such an important material that we cannot answer how to replace it currently. It is, you can say, consumed everywhere. It is concluded everywhere. It's used in design everywhere. Without concrete, in this era, we cannot say that civil engineering can exist all over the world. I can't say quality doesn't exist. It exists in so many countries. Only I'm talking about, though you cannot say in our country, I don't think even people know spelling of quality. In its will, not in article. We don't have will to have quality, and that's where we fail. And somebody has to take care of this, and that someone is everyone. When I say someone has to take care, this doesn't mean any particular person. It is every person, and in engineering, everyone. From fresh engineer to very experienced engineer. But people sometimes take it easily, because I have been writing about quality for many months, but I try to share my experience with many people, thousands of people on Facebook, on LinkedIn, and also on SAFE, and otherwise whatever possible way we can say. But I think people consider quality as not their responsibility. That is problem here. Everybody thinks that it is specialized in its own domain. Design engineer thinks has nothing to do with quality. It takes care of only designs. Think design is expertise. Whereas planning engineer thinks that that person only born for planning. Likewise, every expert is, you can say, part expert. We need people who can move on all these overlaps which are absent, all these bridges to quality. There is no discipline, there is no expertise that can move without quality. Even if it is design has quality, it must be quality design, it must be quality planning, it must be quality quantity surveying, it must be quality contracts, it must be quality dispute resolution. I don't think there can be something that cannot have quality relations. Engineering is full of quality. Manufacturing is full of quality. There is no field in life where quality has not to exist. If you say no need, then we stay in dark world. That's why I always stress communication is a very important part of our life, and documentation is a must. If we can't do that, we can't achieve quality in construction, we can't achieve quality in production, manufacturing, quality in services, quality in education, and quality in society and institution. Communication coordination is that branch. There's no formal branch, but this is important branch because this applies everywhere. In fact, we can say communication coordination engineering, though it's not named anywhere, but it works everywhere. You coordinate, you communicate everywhere, but not in engineering, manufacturing works, in construction works. Some people do, but they're not, we can say, common. And without this, we can't move anywhere. And here is what I say: concrete, that you can say. Let me go to concrete. You can saying, we talked of curing last time. We were talking on this form surface moisture curing, moisture retaining cover curing, and we're talking of this, I think, liquid membrane curing. We talked of steam curing. Let you know, we say that steam curing, steam curing, we may say an enclosure shall be formed around concrete using tarpaulin or other suitable means. We talked of this. Application of steam shall not be commenced. Application of steam shall not be commenced until at least 2 hours after final placement of concrete. Steam shall be applied at temperature between 65 and 80. We talked of this. 65 degrees and 80. Remember this. Steam temperature should be this, not 100 or more. So it should be not, in that form of evaporation. Steam 65 degrees to 80 degrees Celsius is limit. We must understand this, particularly where precasting factory work is done or in cold weather conditions when we are internally. An excessive rate of heating and cooling has to be prevented during steam curing, and temperatures in enclosure shall not be allowed to increase or decrease by more than 22 degrees Celsius per hour. So this is range gradient, you can say 22 degrees per hour. There should be no reduction or increase or decrease more than 22 degrees per hour. If it's 80, it should not fall below, you may say 60 or 58. That's what it means. And 65 should not go above 80. So likewise, we have to say maximum steam temperature should be maintained in enclosure until concrete has reached its specified strength. You may say curing shall ensure that no plastic shrinkage crack occurs. This can be done by protective measures. Protective measures, and what are those? We're talking of plastic shrinkage in pavement and other slabs. What are those measures that we have to see? Curing shall ensure that no plastic shrinkage cracks occur, which can be done by protective measures such as sun shields, wind breaks, evaporation, reducers of fog spraying should be initiated immediately to reduce evaporation. So we have sun shields, wind breaks, evaporation reducers, or fog spraying should be initiated immediately to reduce evaporation. Mats used for curing can either be left in place and kept saturated for completion of curing. Mats used for curing can either be left in place and kept saturated for completion of curing, or can be subsequently replaced by a liquid membrane forming curing compound, plastic sheeting, reinforced paper, straw, or water. Buildings, bridges, so we can say after concrete has hardened and while forms are still in place on vertical and other form surfaces, form ties may be loosened when damage to concrete doesn't occur and water applied to run down on inside a form to keep concrete wet. Care shall be taken to prevent thermal shock and cracks when using water that is significantly cooler than concrete surface. Curing water should not be more than about 11 degrees cooler than concrete. So here is 11 degrees. There was 65 to 80 degrees in steam case, and it is 11 degree difference. Means your water temperature should not be more, less. We can say example is, suppose concrete surface is, let's say, 40 degrees. Let us say it's not exactly 40. Let us say it is 40 degrees. So it should be, your water should not be less than 29 degrees. Immediately following foam removal, surfaces shall be kept continuously wet by a water spray or water saturated fabric, or until membrane forming curing compound is applied. Curing mass concrete. Mass concrete, we talked of this, but again by refreshing, it's very important item. Mass concrete or massive block concrete or massive concrete. Mass concrete is often cured with water for additional cooling benefit in warm weather. However, this can be counterproductive when temperature gradient between warmer interior and cooler surface generates stresses in concrete. It's a very important point. Also, we discussed last time, internal portion and external portion temperature difference. And also horizontal or sloping unformed surfaces of mass concrete can be maintained continuously wet by water spraying, wet sand or water saturated fabrics. For vertical and other formed surfaces, after concrete is hardened and forms are still in place, form ties may be loosened and water supplied to run down inside of form to keep concrete wet. Again, same care shall be taken to prevent thermal shock and cracks when using water that is significantly cooler than concrete surface. Curing water should not be more than about 11 degrees cooler than concrete. Curing shall start as soon as concrete has hardened sufficiently to prevent surface damage. So almost for unreinforced massive sections not containing ground granulated blast for a slag or pozzolana, curing shall be continued for not less than 2 weeks, and for where ground granulated blast for a slag or pozzolana is included in concrete is 2 weeks. Otherwise, in concrete, minimum time for curing shall be not less than 3 weeks. That is for unreinforced surface. For reinforced mass concrete, curing shall be continuous for a minimum of 7 days until 70% of specified compressive strength is obtained. If strength is key concrete performance criteria for construction joints, curing shall be continued until assumption of concrete placement or until required curing period is completed. Curing shall not stop until favorable differential temperature is attained, and at approval of engineer, curing shall not stop until favorable differential temperature is attained, and at approval of engineers. For mass concrete, thermocouples shall be used. To monitor temperature difference concrete. Now we go to next one, that is reinforcement, SARIA. Reinforcement in this journal, and that is scope, references, submittals, quality, requirement or assurance, delivery, storage and handling, reinforcement material, reinforcing bars, welded steel wire fabric, tie wire, inspection, sampling and testing. What is sampling and testing? Cutting and bending of reinforcement, fixing of reinforcement, general welding, mechanical splices, bundling and splicing of bundle bars, examination, electrolytic action, cover, reinforcement, forms and linings, tanking, adjustments and cleaning, protective coatings or reinforcement, epoxy coated reinforcing bars, handling of epoxy coated reinforcement, testing of. Now this this part includes tension, compression, and temperature reinforcing steel. Tension, compression, and temperature reinforcing steel. We can say steel has to take tension, compression, and temperature reinforcing steel is called, including welded wire fabric. We can say tension, compression, and temperature reinforcing steel. Means there are these zones where this is tension zone, this is compression zone, and this is where temperature reinforcing is required. And also including welded wire fabric, WWF we call it, welded wire fabric, and epoxy coated reinforcement. Work includes furnishing, fabrication. What's work there? Furnishing, fabrication, and placement of reinforcement for cast in place concrete, including bars, welded wire fabric, ties, and supports. Now, which sections we have to run through? Miscellaneous and structural precast concrete. Now, the talk is a standard specification for steel strand uncoated 7-wire for prestressed concrete, standard specification for deformed and plain carbon steel bars for concrete reinforcement, specification for low alloy steel deformed bars for concrete reinforcement, standard specification for steel wire deformed stress relieved or low relaxation for prestressed concrete railroad ties, standard specification for filled epoxy coated 7-wire pre-stressing steel strand, standard specification for deformed and plain steel stainless steel bars for concrete reinforcement, and we can say standard specification for deformed and plain stainless steel wire and welded wire for concrete reinforcement, deformed and plain low carbon chromium steel bars specification for cold carbon, specification for carbon steel bars for reinforcement of concrete, specification for cold reduced steel wire for reinforcement of concrete, steel fabric for reinforcement of concrete, specification for high tensile steel wire and strand for pre-stressing of concrete, specification for cell sealing, dimensioning, bending and cutting of steel reinforcement for concrete, welding, recommendation for welding of metallic materials, design of concrete structures, general rules and rules for buildings, epoxy coated steel for reinforcement of concrete, epoxy powder and sealing material for coating of steel for reinforcement of concrete, drawings, simplified representation of concrete reinforcement, quality management system, fundamentals and vocabulary. Then we can say local notes. Steel for reinforcement of concrete, that is part 1, plain bars. Steel for reinforcement of concrete, part 2, with bars. And steel for reinforcement of concrete, part 3, welded bricks. So we have steel for reinforcement of concrete, plain bars, that is part 1, ribbed bars part 2, and welded fabric part 3. Submittals we have to do. This is contract procedure, product data including manufacturer's specification, and installation instructions for proprietary materials and reinforcement across accessories shall be provided. Contractor shall submit manufacturer's records of chemical and physical properties of each batch of billet steel bars and a certificate that life respective material furnished meets requirement for steel reinforcement specified. Manufacturer's records shall include certificates of mill as well as analysis, tensile and bend test of reinforcement. With each three copies of steel test report shall be furnished with each consignment of steel reinforcement. Steel shall be tagged and cross-referenced with mill certificate. Quality requirement. Contractor shall submit to engineer for source approval details of proposed source of supply of reinforcement details. Details shall include chemical and physical tests. Chemical and physical tests of past 6 months, production and whatever independent test results for this period. Details of quality requirement and assurance procedures including ISO 9000 certification if held be given. Contractor shall furnish engineer with a certificate of compliance. Contractor shall furnish engineer with a certificate of compliance for each shipment of epoxy coated bar. Certificate of compliance shall state that representative samples of epoxy coated bars have been tested and test results comply with requirements herein specified. Test results shall be retained by contractor for 7 years. 7 years. A complete set of test results shall also be handed over to client at completion of reinforcement works and be made available to engineer upon request. Storage and handling. On delivery, bars in each lot shall be legibly tagged by manufacturer. Tag tag shall show manufacturer's test number. Manufacturer's test number. Tag shall show manufacturer's test number and lot number and other applicable data that identifies material with certificate issued for that lot of steel. Fabricator furnishes 3 copies of a certification which shows batch number or numbers from which each size of bar in shipment was fabricated. Storage of reinforcement shall be done on a suitable structures, a minimum 450 mm above ground surface to prevent damage and accumulation of dirt, rust and other deleterious matter, means 450 mm above ground surface minimum. Storage of reinforcement shall be done on suitable structures, a minimum of 450 mm above ground surface to prevent damage and accumulation of dirt, rust and other deleterious material. Storage facilities shall be such as to permit easy access for inspection and identification reinforcement bundles to be clearly tagged with bar schedule and bar mark reference. Reinforcement shall not be roughly handled, dropped from a height, or subject to shock, loading, or mechanical damage. Reinforcement shall not be roughly handled, dropped from height, or subject to shock loading. Reinforcement shall not be handled roughly, dropped from height, or subject to shock loading or mechanical damage. Steel reinforcing bars shall be kept clean and free from pitting, loose rust, mill scale, oil, grease, earth, paint, or some other material which may impair bond between concrete and reinforcement. Reinforcement shall be covered to ensure protection from wind-blown dust, condensation, and other deleterious materials. Reinforcing materials. Reinforcing bars is one material. Reinforcement shall be done from acceptable source. Reinforcement shall be obtained from acceptable source. All steel reinforcement requirements of QS. So the minimum grade of 500, you can say QS ISO 6935, minimum grade B500, MPa megapascals of BS 4449, British Standard 4449, British Standards 4449 with minimum grade of B500 MPa, ASTM A615M with minimum grade of 75 or 520 MPa. Deformed and plain low carbon chromium steel bars for concrete reinforcements, ASTM A1035 or ASTM A1035M, ASTM 1022. Well, these are all names, you can read yourself. Standard specification for deformed and plain stainless steel wire and welded wire for concrete reinforcement. Standard specification for deformed and plain stainless steel bars for concrete reinforcement. Other types of reinforcement as approved by national standards. Per project design, other steel grades of less than B500 MP may be used only for stirrups and secondary reinforcement. If steel has excessive surface rust, dust, or other deleterious material, if steel has excessive surface rust, dust, or other deleterious material, steel shall be sandblasted. If steel has excessive surface rust, dust, or other deleterious material, steel shall be sandblasted. Sand for blasting shall not contain materials deleterious to durability of reinforcement or concrete. Sand for blasting shall not contain materials deleterious to durability of reinforcement or concrete. Dune shall not be used for sandblasting of reinforcement. For extreme exposure conditions, that is class X5, protection measures such as epoxy coated bars, low carbon chromium steel bars, or stainless steel may be considered, that is for extreme exposures X5. Protection measures such as epoxy coated bars, low carbon chromium steel bars, or stainless steel may be considered. Welded steel wire fabric. Steel fabric reinforcement shall comply with requirement of QS ISO. When I say QS is this country, I'm talking of this Qatar standards. Don't be confused otherwise. ISO 69353 or BS 4483 and delivered to site in flat mats. Welded inspections. Welded intersection shall not be spared more than 300 mm for plain round bars, that is welded intersections, shall not be spaced more than 300 mm to 300 by 300 for plain round bars and 400 mm apart for deformed high yield bars in direction of calculated stress except when used. Now tie wire. Tie wire, though it's a very important item, it's permanently included and we have to value to this also. Though some people don't query about this, tie wire shall conform to requirements of BS 4482, 1.6 mm, 1.6 mm. Black annealed mile steel shall be used for tie wire. No wires smaller than size D4 shall be used, so 1.6 mm black annealed. I'll still be. Inspection, sampling and testing. Inspection for reinforcing steel and installation thereof shall be conducted by engineer. Contractor shall give 24 hours notice to engineer before closing forms or placing concrete. This is standard one, but sometimes inspectors are flexible in this regard, and it is practical activity, but something is to be given in the specifications, and that's why 24 hours is necessary, but it is not essential. In fact, depends on site links. Now, engineer may instruct contractor to break out and remove completely all sections of work already constructed and reinforcing steel sample under test fails. Reinforcing steel sample under test fails to meet specification requirements at any time. At whatever time means reinforcing steel sample fails. And you can say engineer considers that samples which were presented for test were not truly representative. A previously rejected reinforcing steel has been used in works. Previously rejected and reinforcing steel has been used in work. So, if sample fails or samples that were presented for test were not truly representative, and if rejected steel has been used, so we can say that you have to remove that, and that's what it says, that engineer may instruct contractor to break out and remove completely all sections of work already constructed under any of representative samples of all reinforcing steel. Representative samples of all reinforcing steel proposed for use in works must be submitted. Representative samples of all steel reinforcing proposed for use in works must be submitted by contractor before work is commenced to engineer for its written approval. कोई भी मटेरियल स्टील हो या कोई भी हो, बिना अप्रूवल के, इंजीनियर के अप्रूवल के आप उसको प्रोजेक्ट के काम में लगा नहीं सकते. Represents okay. Manufacturer certificates stating clearly for each sample. First was sampling. Second is manufacturer certificate stating clearly for each sample, place of manufacture, expected date, and size of deliveries to site, all relevant details of composition, manufacture, strength and other quality of steel. Engineer reserves right to sample and inspect reinforcement steel upon its arrival to work site. Frequency of sampling and method of quality control shall be done in accordance with steel bars manufactured coated. Where epoxy coated steel is used, sample of coating material shall be supplied with each batch and an airtight container and identified by batch. Tests shall be carried out. Tests shall be carried out when directed by engineer. Signals problem and also frame problem. Both problems means it has to die. I think maybe I can't say. Tests shall be carried out when directed by engineer. Tests shall be carried out in accordance with QS ISO 6935 or BS 4449. Following information shall be provided with each delivery of reinforcement. Elastic limit. Elastic limit. Ultimate strength. Elastic limit. Ultimate strength. Stress strain curve. Cross sectional area. Deformation bond. Characteristics of deformed bars. What are these? Elastic limit, ultimate strength, stress strain curve, cross sectional area, deformation bond, characteristics of deformed bars. Contract shall allow for dimensions and weight measurements, tensile bend or rebend tests at on cost. For each size of bar to be used in concrete construction. Test results for each bar size shall be submitted to engineer 3 weeks before concrete. Full testing shall be required. Full testing shall be required if source of supply of reinforcement changes. Full testing shall be required if source of supply of reinforcement changes, in which case cost of such extra testing to be borne by contractor. Full testing shall be required if source of supply changes, in which case cost of such extra testing shall be borne by contractor. When test results do not conform to relevant standard, reinforcement steel shall be removed from site and all costs resulting therefrom shall be borne by contractor. Cutting and bending of reinforcement. Cutting and bending of reinforcement shall be done in accordance with ISO 3766 or BS 8666. BS 8666 is revision and before it was BS 4466 and shall be done without application of heat. Bends shall have a substantially constant curvature. For epoxy coated steel, provisions of clause 11.6.1 of this part shall apply. Steel bars manufactured according to approved ASTM standard shall be bent according to same standards. Reinforcement shall not be straightened or rebent. Reinforcement shall not be straightened or rebent without approval of engineer. If permission is given to bend projecting reinforcement, care shall be taken not to damage concrete and to ensure that radius is not less than minimum specified in BS 8666. So it is cutting and bending. It says cutting and bending of reinforcement shall be done according to this code BS 8666 and without application of heat. No heat is applied. Bend shall have a substantially constant curvature, and for epoxy coated steel, we refer to that one. Steel bars manufactured according to approved standards ASTM shall be bent according to the same standard. Reinforcement shall not be straightened or rebent. No straightening or rebent without approval of engineer. If permission is given to bend projecting reinforcement, care shall be taken not to damage concrete and to ensure that radius is not less than minimum specified in 8666. Shall be securely and accurately fixed in positions shown on drawing to ensure that reinforcement steel framework as a whole retain its shape. Within concrete. Ends of all tying wires shall be turned into main body of concrete and not allowed to project towards surface. No part of reinforcement shall be used to support axis ways. No part of reinforcement shall be used to support axis ways, working platform, or for conducting an electric current. Contractor specific attention is drawn to following general requirements. Lapped joints shall not be lap joints shall be as indicated on drawings and or in accordance with requirements of EN 199211 BS 8666. Hooks shall be semicircular with a straight length of at least 4 bar diameters for mild steel and 6 bar diameters for high yield steel. Welding shall not be used unless authorized by engineer and recommended by reinforcement manufacturer. Welding shall not be used unless approved by engineer, and before that it is recommended by reinforcement manufacturer. Where welding is approved, it shall be executed under controlled conditions in a factory or workshop. Welding shall not happen on site without approval of engineer. Welding is a question. It's a good note. Welding shall not happen on site without approval of engineer, and unless suitable safeguards and techniques are employed, types of steel employed have required welding by properties. Welding, if approved, may be used for fixing, crossing, or lapping reinforcement in position, fixing, crossing, or lapping reinforcement in position, fixing bars to other steel members, structural welds involving transfer of loads between reinforcement or between bars and other steel members. So one is, if approved, may be used for fixing, crossing, or lapping reinforcement. Fixing bars or other steel members. Structural welds involving transfer of loads between reinforcement or between bars and other steel members. Length of run deposited in a single pass shall not exceed 5 times bar diameter. Length of run deposited in a single pass shall not exceed 5 times bar diameter. If a longer welded length is required, weld shall be divided into sections with space between units between runs make not less than 5 times bar diameter. Weld shall be divided into sections with space between runs made not less than 5 times bar diameter. Butt welds, not lap, but end-to-end. Butt welds shall be formed by flash built butt welding, or metal arc welding. Metal arc welding or electrical resistance welding may be used for fixing suitable steels or for lap joints. Metal arc welding or electrical resistance welding may be used for fixing suitable steels for lap joints. Flash butt welding shall be executed with correct combination of flashing, heating, offsetting, and annealing using only machines which automatically control this cycle of operations. It says metal arc welding or electrical resistance welding may be used for fixing suitable steels for lap joints. Flash butt welding shall be executed with correct combination of flashing, heating, offsetting, and annealing using only machines which automatically control this cycle of operation. Metal arc welding shall comply with EN 1011 and recommendations of reinforcement manufacturers. So whereas metal arc welding or electrical resistance welding for suitable steel for lap joints, and flash butt welding for butt joints. Flash butt welding shall be executed with correct combination of flashing, heating, upsetting and annealing using only machines which automatically control cycles of operation. Metal arc welding shall comply with this recommendation. Welded joints shall not be made at bends in reinforcement. Weld joints shall not be made at bends in reinforcements. Joints in parallel bars of principal reinforcement shall be staggered unless otherwise approved. Distance between staggered joints shall be not be less than end anchorage length joints. Weldable reinforcement where shown on drawing shall conform how many times have come so far. Wonderful it is, and of course it's difficult. It's come a long way, but how it works, I don't know. How should it works? Mechanical splices I'm talking. Mechanical splices shall comply with EN 199211 or BS 8666. Mechanical splices comply with BS 8666 and be used as and where indicated on drawings. Details of mechanical splices shall be submitted to engineer for approval. Bundling and splicing of bundle bars. Bundling and splicing of bundle bars shall be in accordance with same as said above, that is with EN 1992-1-1 or BS 8666. Splicing except where indicated on drawings or approved shop drawings shall not be permitted without approval of engineer. Examination. Contractor shall notify engineer. Contractor shall notify engineer at least 24 hours before commencing fixing of reinforcement in order to facilitate the inspection of formwork. Contractor shall notify engineer at least 24 hours before commencing of fixing of reinforcement in order to facilitate the inspection of formwork. Contractor shall ensure that areas to receive reinforcements are cleaned before fixing. Contractor shall ensure that area to receive reinforcements are cleaned before fixing. Electrolytic action. Electrolytic action. It's 5 o'clock. I think 1 hour gone. Just a minute, please. Just let me stand up. Relax my jam the legs. I'll leave at about 6 o'clock also. Now, electrolytic action. Electrolytic action we're talking of here. Electrolytic action. Reinforcement shall not be fixed or placed in contact with non-ferrous metal. As the point is, reinforcement shall not be fixed or placed in contact with Non-ferrous metals. Non-ferrous metals. Remember, reinforcement shall not be fixed or placed in contact with non-ferrous metal. This means plastic, right, or some other metal which is non-ferrous. Cover. Correct cover, correct concrete cover to reinforcement shall be maintained with aid of approved spacer places. Cover. Correct concrete cover to reinforcement shall be maintained with aid of approved spacer pieces. Cover shall not be less than given in section 5 part 6. We'll see how much that, generally standard one. Think 20 for slabs. Clear what I'm talking. It may be 30 for beams. It may be 40 for columns. It may be 50 for foundations or 70 for foundations. We'll see what's that one. I'm just commenting on my own experience. Spacers, chairs, and other supports shall be provided as necessary to maintain reinforcement in its correct position. That is spacers, which we call concrete covers. Spacers, chairs, and other supports shall be provided as required to maintain reinforcement in its correct position. In a member where nominal cover is dimensioned to lengths, spacers between links and formwork shall be same dimension as nominal cover. Spacer bars shall be of same diameter. Spacer bars shall be of same diameter as longitudinal bars, but not less than 25 in diameter, and be fixed between two layers at 1.5 meter centers, except where bundle bars are detailed. Spacers, chairs, and other supports shall be made of concrete. That is, spacers, chairs, and the supports shall be made of concrete, plastic, or other material to approval of engineer. The supports are made of concrete. They shall have at least same cube strength as concrete in host member. Placing of all reinforcement steel bars. We're talking of reinforcement. Placing of all reinforcement steel bars shall be checked by engineer, and in no case you can say, and in no case is concrete to be placed around any reinforcing steel bars that has not been approved by engineer. Insertion of bars into or removal of bars from concrete already placed is not permitted. Placing of all reinforcement steel bars will be checked by engineer, and in no case is concrete to be placed around any reinforcing bar, any reinforcement steel that has not been approved by engineer. Insertion of bars into or removal of bars from concrete already placed. Reinforcement steel temporarily left projecting from concrete at joints shall not be bent without prior approval of engineer. Forms and linings. Damage to forms and linings shall be avoided. Tanking. Reinforcement shall not be fixed until completion of placing tanking. Membrane, it's called tanking protection. Reinforcement shall not be fixed until completion of placing tanking protection. Adjustment and cleaning. Check position of reinforcement before and during placing concrete. Check position of reinforcement before and during placing concrete. Pay particular attention to position of top reinforcement in cantilever sections. Ensure that reinforcement is clean and free from corrosive pitting. Free from corrosive pitting, loose rust, loose mill scale, oil and other substances which may adversely affect reinforcement, concrete or bond between two. Protect projecting reinforcement. Protect projecting reinforcement from weather where rust staining of exposed concrete surfaces may occur. At time of concreting, all reinforcement steel shall have been thoroughly cleaned. At time of concreting, all reinforcement steel shall have been thoroughly cleaned and free from all mud, oil or any other coating that might destroy or reduce bond. Clean all set or partially set concrete which may have been deposited thereon during placing of a previous lift of concrete. All uncoated rust bars shall be again sandblasted and pressure washed. All uncoated rust bars shall be again sandblasted and pressure washed. Immediately before concrete placing, reinforcing steel bars shall be washed thoroughly with high pressure potable water just to remove any deposited salts. Immediately before concrete placing, reinforcing steel shall be washed thoroughly with high pressure potable water jet to remove whatever deposited salts. Protective coatings to reinforcement. All foregoing clauses of this part apply equally to epoxy coating. Now, epoxy coated reinforcing bars. Reinforcing steel which are to be coated shall be free of slivers. Reinforcing steel which are to be coated shall be free of slivers, scabs, excessive pitting, rust, grease, oil and other surface defects detrimental to proper coating. Says reinforcing steel which are to be coated shall be free from slivers, scabs, excessive pitting, rust, grease oil, and other surface defects which are detrimental to proper coating. Surface shall be prepared in accordance with ISO 14654. Coating shall be applied to clean surface as soon as possible after cleaning and before any visible oxidation to surface occurs. Reinforcing steel shall not have surface defects that would be detrimental to coating. Coating material shall be epoxy resin powders. Epoxy resin powders as specified for coating of reinforcing bars, and this is as follows. So what you say? First requirement is reinforcement should be free from slivers, scabs, excessive pitting, rust, grease, oil, other surface defects which are detrimental to proper coating, and it should be prepared in accordance with code, and coating applied to clean surface only as soon as possible after cleaning and before whatever visible oxidation to surface occurs. Reinforcing bars shall not have surface defects that would be detrimental to coating. Coating might be epoxy resin powder as specified, and then epoxy resin powder which do not meet above requirements must be tested by an approved independent testing laboratory and accepted by engineer before use. Epoxy coating reinforcement steel will be accepted. Only fusion bonded epoxy coating. Only fusion bonded epoxy coating reinforcement steel will be accepted. Only fusion bonded epoxy coated reinforcing steel shall be accepted. No other means of epoxy coating shall be approved. Only fusion bonded. Patching material shall be furnished by epoxy coating manufacturer compatible with coating. Inert in concrete suitable for repairs to coated reinforcing bars to be made by coating applicator and contractor at project site. So say patching material shall be furnished by epoxy coating manufacturer compatible with coating, and inert in concrete suitable for repairs to be coated reinforcing bars to be made by coating as applicator and contractor at project site. Fabrication shall be performed before coating except as hereinafter specified for bent bars and straight bars less than 7.6 meters. Sorry. Fabrication shall be performed before coating, except fabrication shall be performed before coating, except as hereafter specified for bars bent and straight bars less than 7.6 meter long. Bent reinforcing steel bars shall be coated after bending unless fabricator can show that satisfactory results can be obtained by coating before bending. Any visible, whatever visible cracks, whatever visible cracks in coating on outside on bent or damage to coating resulting in the bonding of coating after bending shall be rejected. Bars less than 7.6 meter long may be sheared or sawn to length after coating, provided end damage to coating does not extend more than 12 mm back. Visually, epoxy coating should be checked visually after cure for continually for continuity of coating. Epoxy coating shall be checked visually after cure for continuity of coating and shall be free from holes, contamination, cracks and damaged areas. There shall not be more than 2 holidays, we can say pinholes, not visually discernible. There shall be not more than 2 holidays, pinholes not visually discernible, discernible in any 300 mm of epoxy coated bar. Holiday detector. Holiday detector shall be used. Holiday detector shall be used in accordance with manufacturer's instruction to check epoxy coating for holidays. 67.5 amp 5-volt detector such as Tinker and Racer model M1 or its approved equivalent shall be used. Patching of holidays is not required if there are less than 3 holidays per 300 mm length. Patching of holidays is not required if there are less than 3 holidays per 300 mm length. Bars having 3 or more holidays per 300 mm shall be grained and recoated or replaced as directed by engineer. Patching, epoxy coating film shall be cured and or of each product, a representative proportion of each product lot shall be checked. A representative proportion of each product lot shall be checked by epoxy coating applicator. You can say a representative proportion of each production lot shall be checked by epoxy coating applicator using method epoxy coating film shall be cured and or post cured to a fully cured condition. Representative proportion of each production lot shall be checked by epoxy coating applicator using method most effective. It is using method most effective for measuring cure to ensure that entire production lot of epoxy coating is supplied in fully cured condition. Contractor shall repair all coating damaged by fixtures used to handle or support bars in coating process as follows. Contractor shall repair all coating damaged by fixtures to handle or support bars in coating processes as follows. Patching shall be contractor shall repair all coating damages by fixtures used to handle or support bars in coating process as follows. Patching shall be done as soon as possible and before visible oxidation occurs. Excessive patching from others cause will not be permitted. Satisfactory correction shall consist of proper adjustment of process. Satisfactory signals problem. I think now 25 minutes, 81% remaining. Okay, so we can say satisfactory correction shall consist of proper adjustment of process and rerunning bars through plant. Satisfactory correction shall consist of proper adjustment of process and rerunning bars through plant. Engineer reserves right for access to epoxy coating applicators plant to witness epoxy coating processes for project work and to obtain specimen from test bars for any testing desired. All chairs, tie wires and other devices used in connecting, supporting, securing or fastening epoxy coated reinforcement steel shall be made of coated with a dielectric material. Before reinforcement is lowered into place and before placement of concrete, coated bars shall be inspected by engineer to damage to epoxy coating. Sheared ends of bars and other areas requiring limited repair due to scars, and minor defects shall be repaired using specified patching or repair material. Handling of epoxy coated reinforcement. Handling of epoxy coated reinforcement. Reinforcement steel bars shall be handled. Reinforcement steel bars shall be handled and stored in a manner to prevent damage to bars or where used epoxy coating. Bars or where used epoxy coating damage cost to employer. Where epoxy coated bars are used at handling system, all handling system shall have plastic mandrel and padded contact areas wherever possible. Where epoxy coated bars are used at handling system shall have plastic mandrel and padded contact areas where possible. Where epoxy coated bars are used at bundling, bands shall be padded. Where epoxy coated bars are used as bundling, bands shall be padded. All bundles shall be lifted with strong back. All bundles shall be lifted with a strong back, multiple supports or a platform bridge, so as to prevent bar to bar abrasion from sags in bar bunks. All bundles shall be lifted with strong back, multiple support or a platform bridge so as to prevent bar to bar abrasion from sags in bar bundle. Bars or bundles shall not be dropped or dragged. During vibration care shall be taken to ensure that epoxy coated reinforcement is not damaged by poker. Testing of epoxy coated reinforcement. Adhesion and flexibility of epoxy coating shall be evaluated on test bars coated with each product lot. At least 1% of length of 6 meters. At least 1% of length of 6 meters. Whichever is less, 6 meters or 1% length or 6 meters, whichever is less. % length of each size of bar to be coated shall be furnished as test bar. Test bars may be in one length or multiple lengths, as required to have one test bar of each size with each production. Production epoxy coated test bars shall be evaluated by bending 120 degrees after remount. Size of bar. Here is table. This is mandrel diameter and bar. This is mandrel diameter for bar diameter, mandrel diameter for bar diameter for evaluation test of epoxy coated test bars. Bar 10 mm diameter, diameter of mandrel 79 mm. Sixteen mm bar diameter, 127 mm diameter of mandrel, and 18 mm means 143, 20, 159. 22 mm bar means 175 mm mandrel, 175 mm diameter of mandrel, and we can say 24 bar diameter, 24 mm bar diameter, 191 mm mandrel, 25 mm bar diameter, 198 mm mandrel, and 26 bar diameter, 206 mm mandrel. 28 mm diameter is 222 mm mandrel. Bends shall be made at uniform rate. Bends shall be made at uniform rate and may take up to 1 minute to complete. Bend test shall be conducted. Bend test shall be conducted at room temperature between 20 degrees and 30 degrees Celsius. After specimen has been exposed to room temperature for a sufficient time to ensure that it has reached thermal equilibrium. No cracking of epoxy coating. No cracking of epoxy coating shall be visible to naked eye on outside radius of bent bar. Joints. Concrete joints. In this we have scope, references, submittals, quality assurance, requirement definitions. Then construction joints, general. Construction joints in water retaining structures. In movement joints, the movement joints is general, joint filler, joint sealants, slip bearings, general water stops, butyl rubber, the stuff, water swelling gaskets. Joints. This part deals with movement and construction joints, slip bearings, water stops, and associated sealants and filler materials. So it is construction joint, movement joints, slip bearings, water stop, and associated sealants and filler material. Related sections and parts are as follows. One is general, that is part 1, then is curing, and there's hot weather conditions, part 15, and miscellaneous, part 16. And references as usual. Standard specification for preformed expansion joints, fillers for concrete paving and structural construction, non-extruding and resilient bituminous type. Standard test method. Standard specification for preformed expansion joint. Filler for concrete paving. Standard specification for preformed expansion joint filler to concrete paving and structural construction, non-extruding and resilient bituminous type. Standard test method for rubber property is durometer hardness. Standard test method for flexible cellular materials made from all-in films. Cellular materials made from olefin polymers. Physical can say standard test method for flexible cellular materials made from olefin polymers, physical tests of rubber, general purpose flexible PVC compounds for molding and extrusion, methods of testing plastics, design of joints and joining in building organized rubber, Eurocode to design of concrete structures, liquid retaining and containing structures. Eurocode to design of concrete structures, liquid retaining and containing structures, cellular plastics, polyethylene method of test, curves of engineer specifications for polyvinyl chloride water stop, and quality management requirement, that is Submittals, contractor shall submit. Contractor shall submit. Contractor shall submit for approval by engineer as soon as practicable. After acceptance of tender in not less than 3 weeks, contractor shall submit for approval by engineer as soon as practicable. After acceptance of tender in not less than 3 weeks before commencement of concreting drawings, showing its proposal for position of construction joints, having due regard to any that may be shown on contractual drawings. We can say that contract shall submit for approval by engineer as soon as possible or practicable after acceptance of tender and not less than 3 weeks before commencement of concreting drawings, showing proposals for positioning of construction joints, having due regards to whatever that may be shown on contract drawings. For slide bearings, contract shall provide at least for slide bearing, contract shall provide at least 3 samples of proposed material together with manufacturer's technical specifications and recommendations in respect of applications and performance. For slide bearings, contractor shall provide at least 3 samples of proposed material together with manufacturer's technical specifications and recommendations in respect of application and performance. For slip joints, this was for slide bearing. For slip joints, contractors shall provide at least 3 samples of materials for no use to speak because recording issue. I talked of slide bearings and slip joints. 3 samples of material proposed together with manufacturer's technical specifications. So let's say for water stops, contractors provide at least 3 samples of proposed types, including prefabricated joints and junctions. If applicable, if joints are to be made up on site, provide work samples. If joints are to be made up on site, provide work samples, including samples for each make of water stop, where samples from different manufacturers are provided. For water stops, contractor shall provide the samples of proposed types, including prefabricated joints and junctions, if applicable. If joints are to be made on site, provide walked samples, including samples for each make of water stop, where samples for different manufacturers are provided. Contractor may supply a certificate of compliance for joint sealants, stating that it meets requirements of specification. Contractor shall also supply manufacturer's technical and installation data for proposed materials. Contractor shall provide details of previous installations of product with clear client name, structure name, type of joint, and value of contract. There was about slide bearing we discussed, about slip joints we discussed, the water stops we discussed. So we can immediately go drawings that show layout of water stops, special and joints. Quality requirement. Signals are down again. Quality requirement. Joint sealant, including primers and debonding materials, compatible with each other, be supplied from manufacturer operating quality system. Definitions. What is construction joint? Surface where two successive placements of concrete meet, across which it is desirable to develop and maintain bond between two concrete placements, and through which reinforcement which may be present is not interrupted. This is construction joint. What is contraction joint? Formed, sawed, or tooled groove in a concrete structure. Formed, sawed, or tooled groove in a concrete structure to create a weakened plane and regulate location of cracking resulting from dimensional changes of different parts of structure. That is contraction joint. Formed, sawed, or toothed groove in a concrete structure to create a weakened plane and regulate location of cracking resulting from dimensional change of different parts of structure. So it's a groove in cut, since a formed, sawed, and tooled groove in a concrete structure to create a weakened plane and regulate location of cracking resulting from dimensional change of different parts of structure. Expansion joint is separation between adjoining parts of a concrete structure, which is provided to allow smaller relative movement, events such as those caused by thermal changes, to occur independently. Isolation joint is separation Isolation joint is separation between adjoining parts of a concrete structure. Is separation between adjoining parts of a concrete structure provided to isolate an element and thus allow independent movement. Joints fillers, materials that are used to fill spaces within movement joints during construction. They may provide support to sealant applied. I will not move any further in this case. Maybe I take consider joints for time being, because it's generally a very important item. It's not design actually. It's not a design, where construction joints are required. In slabs or beams designed by direct design method, they shall be located within middle third of their spans, and at 1/3 to 1/4 of span in slabs and beams. It says where joints are required in slabs or beams designed by direct design method, it shall be located within middle third of their spans and 1/3 to 1/4 of span in slabs. Beams subject to maximum spacing of approximately 9 meters. Where slabs are supported by beams, then beams and slabs shall be constructed in one operation. Where slabs are supported by beams, the beams and slabs shall be and concrete shall be thoroughly compacted against these stop boards. Where slabs, beams and walls incorporate construction joints, panels shall generally be constructed consecutively. Where this is not possible, a gap not exceeding 1 meter shall be formed between adjacent panels. This gap will not be concreted until a minimum meter of 7 day has expired since casting off.